Hello everyone, I want to welcome you to another section. In this section I'll be talking about how to get Km, Vmax and Ki when you are given data of an enzymatic reaction. So this is the question we are going to be discussing in this particular video. In the picture shown to you, the question contains a table of value where we are given the substrate concentration, at the same time the velocity of the enzymatic reaction in the presence of no inhibitor, at the same time the velocity in the presence of inhibitor A, at the same time the velocity in the presence of inhibitor B. So in this case now, that implies that we are going to get like three lines, or let me say like three graphs from this particular data. One for the reaction when there is no inhibition, one when there is inhibitor A, and the last one when there is inhibitor B. So you have to get like three lines, or let me say like three graphs from this particular data. So what's the next thing? The next thing is to change. Before you can plot your graph, you have to convert your S to 1 over S, at the same time to convert your V's to 1 over V, because in getting Lineweaver plot, you are plotting 1 over V against 1 over S. So you have to create a table, you have to convert your data, that is your S to 1 over S, at the same time your V to 1 over V. After you have done a conversion of the given original data and you have gotten the reciprocal of the substrate concentration and the reciprocal of the velocity, then you have to plot your graphs. So the graph from this particular data, after conversion of the table of value, after conversion of your values to 1 over S substrate concentration and 1 over V, then the next thing is that we have the graph as displayed on your screen. Now from that particular graph, you will notice something, that they got a graph like this, they got like, we have something like this, and we also have something like this, and we have another one particularly like this. So now this is for no inhibition, this is for inhibitor A, and this is for inhibitor B. So this is for inhibitor B, this is for inhibitor A, and this is for no inhibitor. Now looking at this now, how do I get Vmax, Km, and then the Ki? The first thing to talk about is to look at this graph and determine what kind of inhibition do you have. Now if I am going to look at this inhibitor A, comparing this inhibitor, the graph of this one that contains inhibitor A with no inhibition, you will see that the two lines have the same y-intercept but different slope, and that implies that it is a competitive inhibition based on what we have talked about in the previous video. So looking at your graph barely could help you to know what kind of graph, what kind of inhibition you have. And don't forget what I said, you are plotting 1 over V against 1 over substrate concentration. So, and that's why I started with the fact that you have to convert your data, that is your substrate concentration, to 1 over S, and then your velocities to 1 over V, and then use that data to plot your Lineweaver plot, which is going to look like this. So from this place, like I said, looking at this inhibitor A, the line of inhibitor A compared to the one that has the inhibitor, you can say that these two lines have different slope but the same y-intercept, and that makes it a what? That makes it a competitive inhibitor, that is inhibitor A. But looking at inhibitor B and no inhibitor and the one that has no inhibitor, that is this line and this line, we will see two things: different y-intercepts, that is the y-intercept here is different from the y-intercept in this case, and therefore at the same time the slope also is different. So in this case now we are having different slope, different y-intercepts. This kind of property has to do with when you have a non-competitive inhibition where both the slope and the y-intercept are different. Now the first thing you have to do is that you have to find the slope of this line, find the slope of this line, find the slope of this line. When you are doing your exam, it's very important that you calculate the slope of this line. At the same time, you read your y-intercept along the y-axis. But in this particular video, I'm going to give us the equation of each of these three lines from which we can get the slope, at the same time the y-intercept. For this one that has no inhibitor, the equation of this line for no inhibition is given by y equals to 302.5, and we have x plus we have 196,000. So that implies that for no inhibition, the slope of this line, relating this to your y equals to mx plus c, the same, that means that the slope of this line is 302.5, while this y-intercept here is 196,000. So, but in the exam, they will expect that you calculate your slope from this line by doing this, get your change in y, get your change in x, and use that to get the slope. At the same time, read the y-intercept along the y-axis, and that's how you can get an equation like this. For this one that has inhibitor A, we also do the same thing for inhibitor A. So let me write that for IA, the equation is also y equals to 757.8x plus 203,000. Now, if you look at this now, you can see, like I said, that the slope of this one and the slope of this is very different. But in terms of y-intercept, the y-intercept of the two is what? They are very close. Approximately, the two of them is 200,000. If you approximate this intercept here will be 200,000, and when you approximate this, the intercept will be what? So in some cases, the intercept might not be exactly the same for the two lines, but they should be very close if at all they are going to be a competitive inhibitor. So, but from the shape, from this line right there, I already know that the two lines I have here for this one and this now is a competitive inhibitor, because the y-intercept is the same. At the same time, the y-intercept is the same, why the slope is what is different, and that can be seen in the equation of those two lines. So, but the major point I want to drive at is that it is not compulsory that the y-intercept you are going to get for the two lines should be exactly the same. And for this last line that we have here, which have different y-intercept from these two, at the same time different slope from these two. So the equation for the line of inhibitor B is y equals to 1015.3x plus 595,000. Now you can see that the difference between this y-intercept for this third line is far different from what we have in these two lines. So this already shows us that inhibitor A is a competitive inhibitor compared to the line of no inhibition, while inhibitor B compared to this line is a non-competitive inhibition because the slope and the y-intercept is different. So how do I now use this data? To get my Vmax, my Km at the same time my Ki. So like I said in the previous video, so the first thing you could get is to get your Vmax from the y-intercept, because we said that y-intercept, we said in the previous video that y-intercept of Lineweaver plots is equals to 1 over Vmax. So I could get the Vmax in this case, the Vmax in this case, and the Vmax from their y-intercept. So this is the y-intercept for the line of no inhibitor, this is the y-intercept for the line of inhibitor A, and this is the y-intercept for this inhibitor B. So we can easily use this expression to get our Vmax. So in a way, the Vmax for no inhibition will be 1 over 196,000. The Vmax for inhibitor A would be 1 over 203,000, and then the Vmax for inhibitor B will be 1 over 595,000. Now this, like I said, so you can see that you will use the y-intercept of each of the line to get the Vmax, and getting the Vmax, I can now use this Vmax to get the Km for each of these lines. So if I get the Km for this line, I want to get the Km for no inhibitor, what do I do? So like we said slope. In the previous video, we said slope of these lines is always equals to Km over Vmax. So now that we've already gotten our Vmax from the y-intercept, we can put the Vmax here together with the slope of each line to get the Km. So let's start like we did for this now. So the Km for no inhibitor, would be, so that would be Vmax times the slope. So what is the slope of no inhibitor from this line? That's 302.5. I want to believe that we can calculate the slope of a straight line at the same time the y-intercept of a straight line, and that's how we got this equation. But you can always do that after you have plotted your graph correctly to get the y-intercept of each of the line at the same time the slope of each of the line. So from this place now, we have that Km. So the Km for this no inhibitor will be equals to the Vmax of the inhibitor, which is of no, which is 1 over 196,000 multiplied by, what's the slope of this? That's 302.5. So multiplying this Vmax and the slope will give us the Km for no inhibition. This one is no inhibition. For the one that contains the Km for inhibitor A, that will be the Vmax of this case, the Vmax for inhibitor A multiplied by the slope of this line. That will also be 1 over 20300 multiplied by 757.8. But don't forget what I also said, the fact that the slope, the Vmax for inhibitor A at the same time the Vmax for no inhibition would be the same, would be approximately the same. So the value, even though the values we have here are different, but they are approximately the same. So in a way, we expect that the Vmax we're going to get here and here should be approximately the same. But the one you are going to get for this inhibitor B should be completely different, because even from your graph, you'll be able to see whether which lines are having the same y-intercept, which lines are having different y-intercepts. So I've already gotten the Km for for inhibitor A, and that's where we have 1 over 203,000 multiplied by the slope, which is 757.8. And lastly, the Km for inhibitor B will be 1 over the y-intercept. The Vmax here is 1 over 595,000, and then multiplied by the slope of the line, which is 1015.3. So with this one, you can get the Km of inhibitor B. With this, you can get the Km of inhibitor A, and with this, you can get the Km of no inhibition. So from these things that I've done now, from these equations of each of the lines, I've gotten the Vmax, I've gotten the Km for no inhibition, for the one that have inhibitor A and for the one that have inhibitor B, and that's how to go about getting your Vmax and your Km. But at the same time, like I said, it is very important that you plot correct graph. At the same time, you should be able to determine the y-intercept from the graph, at the same time the slope of each line from your graph, and then with the slope and the y-intercept you can create an equation, like a straight line equation like this, for each of these lines before you now start to get your Vmax and your Km. But you need to calculate your Vmax first by doing 1 over y-intercept before you now use your Vmax together with the slope to get the Km for no inhibition, for the one that has inhibitor A and for the one that have inhibitor B. Now let me also bring this in some cases. Some people also try to extrapolate Km from the graph by extending their graph to the negative x-axis. Now so in a way you can also get your Km by getting the x-intercept of each of these lines. So the x-intercept of each of these lines can also be used to determine the Km. So if you extend this line towards the back, let's say probably you extend your x-axis and it has negative part. So when you extend each of these lines towards your negative axis like this, these points where this line touches the x-axis can be used to also evaluate the value of Km. So whether you use the x-intercept to get your Km or whether you use the Vm and the slope, you should still get the same thing. So whichever works for you. You can get the Km from this x-intercept. You can use the slope of the line together with the Vmax to get the Km of each of these particular line. At the same time, like I said, you can also use the x-intercept. But most times, if you want to get your Km from the x-intercept will always be equals to minus 1 over Km. Just like we are saying that y-intercept equals to 1 over Vmax. In the same way, s-intercept will always be equals to minus 1 over the Km. So you can also use that particular expression I've just mentioned, that is s-intercept of your that equals to minus 1 over Km. So you can also use the s, but if you are going to get the s-intercept, that will imply that your x-axis will have both positive and negative axis. And knowing where this line, each of your line meets, knowing where each of this line meets the x-axis will help you to get the Km. The difference is that here we have that s-intercept equals to minus 1 over Km, but if it is for y-intercept, that's only 1 over Vmax with no minus. But I said that apart from this method, you can also get your Km using the slope of the line. That is after you have find the slope of each of this line, together with the Vmax that you have calculated initially, and that's how to get the Km at the same time in Vmax. So the question now is, how do I get the Ki? So like I said, to be able to calculate the Ki, you have to understand some of the things that I said about each of these different types of inhibition. For example, for competitive inhibition, I said in the previous video that in a competitive inhibition graph, there will be the same Vmax but different Km. So you can use the difference in the Km to get your Ki. And I said in the previous video that the Km of the reaction that contains inhibitor will be more compared to the Km of the one that has no inhibition, because the presence of a competitive inhibitor will reduce the affinity of the enzyme for the substrate, and that's why we are having an increase in the Km. So in a way, I could say that Km, so for me to get the Ki for this inhibitor A, I could, since I know that it is a competitive inhibitor, so I could say that, and I know that for a competitive inhibition, the Km is always different while the Vmax is always the same. So I can simply say that Km for what? For IA will be equals to Km for no inhibition into bracket 1 plus I over, that is concentration of the inhibitor, over Ki. So what is the Km that we got for the line of enzyme reaction that contains inhibitor A? That's 1 over, so we are getting, that's what? That's 757.8 over 203,000. That's our what? Our Km will be equals to, what's the Km that we get for this line that has no inhibition? From this space that we have, we got 302.5 over 196,000 into bracket 1 plus 0.008, and then we have over Ki. So with this now, I could get my Ki. So I could just walk around this expression to get my Ki, that is the inhibitor constant for this inhibitor A. The same way, but if I want to work for this particular inhibitor B, like I said, is a non-competitive inhibitor whereby the slope is different compared to the one that has no inhibitor. At the same time, y intercept is different. But I said for a non-competitive inhibitor, the Km would be the same while the Vmax will be different. So you can use the different Vmax in order to get your Ki for this inhibitor B, because Km is the same while the Vmax is different. So in that particular case, I could say that the Vmax of inhibitor B will be equals to the Vmax of no inhibition, which is what we got here. So like I said in the previous video, the presence of a non-competitive inhibitor will reduce the Vmax, but we keep the Km to remain constant. So in this case, we are going to have Vmax over open bracket 1 plus I, and we have over what? Over Ki. So in the first case, like I said, in a competitive inhibition, the Vmax remains the same while the Km is different. In a non-competitive inhibition, the Km will be the same while the Vmax will be different. At the same time also, the Vmax in this case, in a non-competitive inhibition, will reduce, while Km in a competitive inhibition will increase. But when it comes to uncompetitive inhibition, where both Vmax and Km is different compared to the reaction that have no inhibition, in such particular case, I said in the previous video that both the Km and the Vmax will do what? Will reduce. And in that particular case, you can divide the Vmax, either the Vmax or either the Km of either the Vmax or the Km of the reaction that has no inhibitor by this particular factor, which is always 1 plus concentration of inhibition over the Ki. So anytime a kinetic parameter is reducing compared to the kinetic parameter of the reaction that has no inhibitor, you have to divide by this factor. But anytime a kinetic parameter is increasing compared to the kinetic parameter of the reaction that has no inhibition, you multiply with this thing. So and that's why in the first case I was multiplying with 1 plus I over Ki. But in this case now, where I have a non-competitive inhibition, I'm dividing by what? By this particular factor. So the same thing still works. What's our Vmax for inhibitor B? From this, that's 1 over 595,000 equals to, what's the Vmax for no inhibition? From what we have, that's 1, and we have 196, and we have 000. into bracket 1 plus, sorry, that will be divided by, then we have 1 plus 0.00, permit me to rub this, so that will be 1.008 over Ki, and then you can get the Ki for inhibitor B, and that's how to get your Ki. But take note, like I said, for an uncompetitive inhibition, you can use either the Km or the Vmax, and in that particular case, both Km and the Vmax are both reducing, and that means that by the time you want to get your Ki, you have to divide the what, either the Km or the Vmax of the reaction that has no inhibition by this particular factor. So the difference between the kinetic parameter of the reaction that has no inhibitor and the reaction that contains your inhibitor is this factor. But it is either this factor increase the kinetic parameter of the reaction that has inhibitor compared to the one that has no inhibitor, or it decreases the kinetic parameter of the one that have inhibitor compared to the one that does not have an inhibitor. And that's what you can do to get your Km, your Vmax, at the same time your Ki. So I would want to refer you to the previous video so that you can have a better understanding of what happens in different kinds of inhibition that we have. And another thing that's also very important that I want to talk about is in the case whereby they can ask you to calculate the turnover number, like I said. But in that case, they would have given you the amount of total enzyme that was used in the particular enzymatic reaction. So in a way, you can be asked to get, like I said, the turnover number. And I said in the previous video that Vmax, that is the maximum velocity, equals to the turnover number multiplied by the total enzyme concentration. So if they have given you the total enzyme concentration in the question and you've already gotten the Vmax from the graph like this, then you can get the turnover number, and that's how to go about in this particular case. So basically, this will be the end of all that I intend to talk about in this particular video. I hope if you have any questions or any comments, you can do it to drop it for me in the comment section. I'll be glad to respond to your questions on this particular subject. Thank you for watching, and I hope to hear back from you. And don't forget to subscribe to this channel at the end of this video. Thank you so much.